Thank you everyone for joining. My name is Lina Rico Gomez. I am the chair of the Climate Positive Working Group for the Better Building Partnership Program. And I'm here with the team at Candle. We want to introduce you to the electrification resources for asset managers and facility managers today. And we are keen to hear from you, so please feel free to put questions in the Q&A option at the bottom, and we'll be answering those questions towards the end of the webinar. So thank you everyone for joining. I think we can go to the next slide. Well, in the meantime, I thought we had a slide for acknowledgement of country, but before I hand over to Dave, I want to acknowledge the traditional owners of the land. For me, that's the Garigal land, Garigal land, and I want to acknowledge the present, past, and emerging generations. And with that, I'm going to hand over to David Clark from Positive Zero. Previous, he was also in Candle, supporting us with this work. So thank you very much.
Thanks, Lina. Welcome, everyone. And look, a great pleasure to be here today to provide an overview of this electrification resource pack developed for the Better Building Partnership and with the City of Sydney. And the Cundall team. So my job today is just to take you through the resource pack. It's all available online, and just to I'm not going to go through it all in huge detail. We're going to probably spend the next 25 minutes, half an hour, just taking you through what's in there, and then we can have a Q&A session. So if you've got any questions, please type them into the Q&A box as we go. And before I start, I'd also like to acknowledge the Camaragal people from whose land I'm presenting to you today. So basically, this resource pack is aimed to get us from gas to no gas. So how do we, in the existing building stock, which is a major challenge, how do we get all the gas out of our existing buildings? And asset managers and facility managers are going to have a key role to play in that. So the steps here is a very high level is just setting the goal. We want to get gas out of the building. And then how do you plan to do that? And then there's the design stage about appointing consultants, and then basically implementing it to get the gas out. And the resources, there's 5 resources there that align with those stages of the project around sort of the goal setting, doing the feasibility study, and then engaging consultants to do the detailed design. So these are the 5 resources. There's a link in the chat to that where you can download those from the Better Building Partnership website. So there's 5 documents. Why should we be electrifying? I've got a brief summary of that. A process flowchart to take you through the steps of electrification. Some guidance on how to put a business case together, particularly around putting a case around the feasibility stage. So we'll talk about that in more detail. The Feasibility Study Tool, which is the sort of the heart of the resource pack. And then there's also a design consultant scope that you can use to go out and engage consultants to undertake some of the design component. So the first resource is why electrification, which is really just a summary of what the key drivers are. And we've done this to be read in conjunction with the Green Building Council Australia's practical guide to electrification for existing buildings. If you haven't read that already, it was launched last month. I'd really encourage you to go and have a look at that. It provides a sort of an overview of the challenge. It provides details on the drivers and some of the issues that need to be addressed. What this resource pack does is take that guide and take it to that next sort of level of detail down for asset managers and facility managers to use. So the why electrification summary is literally just one page, high level summary. What are the key reasons for getting gas out of your building, around climate change, around zero carbon targets, the demand from investors and finance, reputation and branding, resilience and risk, particularly around the volatility of gas prices, and then finally, tenants and health and well-being benefits of not, particularly with gas cooking, using that inside buildings. And there's some key talking points there. So that's a very high-level summary, but please go and have a look at the GBCA guide. The business case guidance, which I'll talk about shortly, also has a bit more detail on those key reasons. The next resource is a process flow chart. So what are just a high-level overview of the key steps to go through in electrifying a portfolio, starting off with a zero carbon target, working through the feasibility business case, and then undertaking a feasibility study, rolling that into an implementation plan across the portfolio, then preparing business cases for individual buildings to go and fund those projects, doing the detailed design, and then tender installation. So in this resource pack, in this guide, there's a page on each of those steps. So, for example, on here, they've got set the zero carbon target for the portfolio and agree that has got to include not having natural gas in the building after a certain time frame. So what it does, it gives you some guidance on each of those steps, what the time frame might be, recognizing that every organization is at different stages of this journey, and there's different sizes of portfolios, and then where you can get further guidance on setting a zero carbon target. Step 2 looks at the feasibility business case. So, to get gas out of a portfolio involves looking at a lot of buildings, and every building is unique. So the first step is to go and look at the scale of the issue and what it's likely to involve. So the first part of that is getting a business case together to do a feasibility study across the portfolio. So there's a bit of guidance there on what's involved, and again, where you can get further information. And then actually undertaking the feasibility study of, what are all the key technical issues that need to be considered in how you're going to get gas out of the existing building. And obviously there's a lot of challenges, and every building will have different opportunities and different challenges. So that's that sort of process steps. Then we've got some business case guidance. So how do you put a business case together for a feasibility study? And then there's also some guidance on how to put a business case together for the electrification projects following the feasibility study and the implementation plan. And it's sort of acknowledging that to do some of this work is going to need specialist input. And I'll provide a bit more detail on that business case guide shortly. There's then a feasibility study tool. This is a spreadsheet tool, covers a lot of the technical issues and has a lot of the technical guidance. And again, I'll talk about that in more detail in a moment. And then the final scope is a Word document, which is a sample design consultant scope that you can use as a starting point when preparing a scope of works to go out to get prices from consultants and specialists to help in delivering the design of electrification in individual buildings. So the business case guidance for a feasibility study. So the first thing is, what are the key issues to consider around the sort of business drivers? And then what is the scope of works that's going to be needed to do the feasibility study? What's the cost of that study going to be? How do you put an estimate of that together? And what are the likely deliverables as a result of undertaking the feasibility study? So for each of the 5 sort of core business drivers, there's more guidance there. You can use this as to help you construct a business case, cut and paste in which components work and are most appropriate for your organization. And there's references around where any of the statistics and the statements have come from. I think it's important to acknowledge that the drivers are changing all the time. And so this is just giving you a really good starting point about how to construct the business case around those drivers. You know, and we're seeing in particular in investor demand and sustainable finance that is just taking off at a rapid rate. We're also seeing things like the CREM, the Carbon Risk Real Estate Monitor, being used to look at whether an asset is deemed stranded or not, and the EU taxonomy is also starting to become a major thing for investors to look at how they consider the value of assets and the climate risk of those assets. And obviously buildings with natural gas in are not going to be considered going forward as low carbon buildings. So that's one of, there's lots of reasons to get gas out of buildings, and this provides you some guidance on those. Then you get into the nuts and bolts of what is the scope of work for the feasibility study, because this is where you need to assess every building in the portfolio. You can't just take a blanket approach. Every building is going to have unique challenges and unique opportunities. You know, what's the type of systems in the building? What's the gas consumption? Who owns the systems? What do existing leases say about provision of gas to tenants? And then all the technical, spatial, ventilation, electrical issues. And we'll talk about that in a bit more detail in the feasibility study tool. Then there's the estimating the cost to undertake a feasibility study. And again, this is going to vary for every organization and every portfolio. Again, there's some guidance here on, you know, what are the typical items that need to be considered when doing the feasibility study, and how many hours might that take per building typically, so you can start building up a cost in your business case on what it's likely going to cost to undertake that feasibility study across the portfolio. And then, you know, finally, what are the deliverables that you're going to get from the feasibility study? So how are you going to, after you've got to collect all this information, how do you pull that together to create an implementation plan? How are you going to present that information back to sort of senior management or the board? And some suggestions there around the overview of the portfolio and the extent of gas use, which gives you the extent of the challenge. What are the summary of the key solutions that you might be adopting? How do you align the implementation plan with other plans for the portfolio? So refurbishments, major lease renewals coming up. Are you going to put in new end of trip facilities, electric vehicle charging? So there are other things going on in the different properties that you can align an electrification project with. How are you going to roll this out? How many buildings per year? And how long is it going to take in each building to deliver that? And then obviously, what's it going to cost? And what's the life cycle cost benefit, including what are the risks of not doing it from a cost perspective? So the next tool is the feasibility study tool. This is a spreadsheet. It's structured like this. It's got a whole series of checklists that you can work through with guidance provided. And I'll take you through some of those. I'm not going to open up a spreadsheet, but I'm just going to take you through some of the key items that it addresses. There's further guidance available, including some flowcharts And then at the end, there's some life cycle cost estimation tools that you can use to assist you in building up CAPEX and energy and carbon cost estimates. Guidance on how to use the tool. You can enter data in the yellow cells or text and so on. It's all set up. Some of them are drop down menus, so it's pretty straightforward. It's set up that the spreadsheet is for one building. So if you've got multiple buildings, you would complete the spreadsheet for each building. The sheets are not password protected, so the password is blank. So this is entirely editable. So if you go in there, you can unprotect any of the sheets and edit it to suit and customize it to suit your organization, change the formatting, do anything you like with it. The only reason there's a password protection, or they're protected with a blank password, is just to stop accidental editing by people. So you can take it and adapt it however you like. There's some flowcharts provided in the tool. We're going to make these available as separate PDFs as well, so that they're not just inside the spreadsheet tool. So they'll be available probably next week sometime on the Better Building Partnership website. And this is just a sort of simple yes/no process. So here's an example from the space heating flowchart. It just takes you through. Have you got gas used in the building? Yes. Have you got gas boilers? Okay. What type of heating system is it? And you can see it starts working through a series of questions to help guide you on what the potential solutions might be and what the key issues are to consider. And anything in the light blue is an action that needs to then be addressed. So it's basically a sort of logical step through all of the key issues around spatial considerations, ventilation requirements for heat pumps. Will that have an impact on planning? Will you need acoustic studies done because you're locating heat pumps on a roof? Say it might be next to a residential. So are there issues there around planning, around structural, etc., etc.? So this is trying to give you some guidance on the issues and things to work through, and then finally, what are the impacts on the electrical demand, and how do you sort of work through that? And this is a very much a simplified flowchart. The rest of the tool has much more guidance on what each of these issues are. And the domestic hot water flowchart is very similar. It's just the start's different between local water heating and central plant with gas boilers. So like I said, we'll make those available shortly as single page PDFs. So then you get into the heart of the tool, and it asks a series of questions. So the first thing is to fill in the details of the building. And it's important that in the gas uses in the building section, you identify what the gas systems are. So has it got gas for space heating? Is it using gas for domestic hot water? Have you got gas appliances in for cooking? Is there gas cogen? I think it's also worth at this point highlighting that this would be, if you don't have submetered gas consumption available for those uses, if there's only like one gas meter for the space heating and domestic hot water, this would be a really good time to start putting submetering onto those gas systems so that you can get a much better understanding of time of use and of actual peak demands, and then use that information to design the electric alternative rather than just trying to do almost a like-for-like replacement in terms of capacity. Then we get into the various sheets that cover the different systems, and they take you through a whole series of questions and information that will be useful in identifying what the potential solution is. None of these cells are mandatory, but the more information you can collect, the more you'll be able to come up with potential solutions, even at a concept level as part of the feasibility study. So there's separate sheets provided for space heating, domestic hot water, cooking, cogen, and diesel generators, even though that's not really about electrification, it's more just acknowledging that diesel is another major source of fossil fuel use in buildings. So it asks you questions on some of the key issues. There's guidance on the right-hand side. And again, like I said, this is all totally editable, so you can change it to suit your needs. So this here just gives you a bit of an overview for space heating. So what is the system you've got in the building? What's the age of the system? Have you got drawings available for it? What do you know about the gas system that's in there? A whole series of questions around sort of capacity, demand, and consumption. What's the actual peak demand versus what is the capacity of the boilers that are in there? Have you got trend logs available? And then, you can enter an estimate of what you think the heat capacity of the heat pumps might be, and what the area of those might be at that point as well. Going through into what the plant room is, what's the current plant room? Is the plant internal or is it external? Again, if it's an internal, does it have the space? Does it have enough natural ventilation? Will you need to do structural checks? Will you need to look at vibration issues? Will you need to find an alternative location to install the equipment? And this is where every building is unique. And then for space heating, there's issues around the actual space heating system. Heat pumps work more efficiently at lower temperatures. Was your space heating system designed for 80 degrees flow, 60-degree return? It's unlikely you can just stick a heat pump onto that. So then you need to start doing an evaluation of what capacity you can get out of that system and how much modification is needed to the pumps, the pipework, the coils, etc. For electric cooking, questions here. Cooking is much, apart from the electrical demand issue, which is obviously a major issue. Getting cooking is about engagement with tenants, and how do you engage with tenants to get them to switch from gas cooking to all electric? And that is a particular challenge, and there'll be leasing agreements in place. So this is much an engagement issue as it is a technical solution. So again, it starts asking the questions and giving some guidance. And I think at this point also worth noting that the Global CookSafe Coalition launches in Sydney on the 22nd of November. And that's a coalition dedicated to showcasing the health and climate benefits of electric cooking, both to the public and residential sector and to the F&B sector. And they'll have high-profile chefs demonstrating what is possible and encouraging the electrification of that sector. So that's something to keep an eye on for, because one of the questions that regularly comes up is where can we get guidance on electric cooking? There's a series of questions around the review of the electrical capacity. This comes up time and time again as a perceived barrier to electrifying buildings. So this starts to ask the questions, what is the existing capacity? What is the actual peak demand? Not the design demand, but what is actually the measured peak demand? What would the new peak demand be due to electrification? Are you adding other electrical loads to the building? Have you considered energy reduction and demand management? So this diagram here sort of breaks that down. This is taken from the Green Building Council practical guide, but just sort of helps visualize what the key issues are. And electrifying a building may or may not increase the peak demand. It depends, for example, on what is driving the summer peak versus the winter peak. It's a good opportunity to really start thinking about what else can you do in the building? Are you adding electric vehicle charging? That's going to have an impact on the demand. And then what demand management and energy efficiency measures can you introduce to pull the electrical demand down of the building? So all of those things are worth considering. If you're going to electrify the building, it's worth thinking about the EV charging in the future as well. So you only have to do, if you have to do upgrades, you only do it once. And then finally, there's the a section that assists with costing. So this is a simple CAPEX template. It doesn't give you guidance on what the costs are, because that's going to vary for every building, but it gives you a list of all the things to make sure that you've considered what the cost of those might be. And then there's a simplified energy cost estimator. So, if you don't have sub-metering information, you can but you know what the gas consumption of the base building is, you can sort of make a rough estimate of what you think the split is between space heating and domestic hot water, typical boiler efficiencies, heat pump efficiencies, and start to be able to do a comparison between maintaining the gas system and putting in an all-electric system. It allows you to enter different gas and electricity tariffs and you can make assumptions on how much you think the energy price is going to change each year. So you can have your typical, a low estimate and a high estimate. And then it calculates over whatever period of time you want to evaluate it for, what those different life cycle costs are. And all the information, the workings of that are all completely transparent. So you can use that to plot graphs, etc. And then there's a carbon cost estimator that takes that information, allows you to look at what you think the grid electricity decarbonisation is. So there's some suggested factors in there, but nobody can predict the future. So you can put your own numbers in there. You can estimate your cost of carbon offsets, sort of typical, low and high, and again, what you think the cost increase might be, and start to do some what if scenarios with different prices over different time periods. And again, that can be useful for your as part of your business case. So that is a fairly rapid run through the resource pack. It's available to download from the Better Building Partnership website. There's a link to it in the chat. There's 5 tools. So the Feasibility Study Tool is the big one. And with that, I'd like to encourage you, if you've got any questions, to type them in the Q&A box, and I'll hand over now and introduce Garrett Shop, who's the Managing Director of Cundall in Australia, to chair a Q&A session. So
thanks, Dave. Thanks for running through the electrification resource pack. We're not flush with lots of questions, so I'm going to throw a few at you from me until maybe someone types a few in. But one of the ones that comes up a fair bit is, will electrifying my building have an impact on my neighbours' rating?
Yeah. I think the answer to that is, look, it does at the moment, but neighbours are currently working through that issue because they also recognise it's really important to encourage the electrification of buildings. They're also recognising the grid decarbonisation as well, which neighbours hasn't necessarily kept pace with the rate of electricity grid decarbonisation and the factors that were used. So that is, I'd say, watch this space, but the risk is rapidly reducing and you'll be rewarded for electrification. And the neighbours rating also will highlight how much of the energy of the building is from renewable sources. And natural gas isn't a renewable resource, so you'll never be able to show 100% renewable energy if you're using gas. It's probably also worth pointing out that Green Star as well, both Green Star Buildings and Green Star Performance, are driving the electrification of buildings, and they've set timeframes. So in existing buildings, Green Star Performance version 2 that's just come out sets a clear trajectory to get gas out of buildings, starting with the 6-star ratings and working through by 2040. All ratings have to have gas. Even if it's a 1-star rating, you need to get gas out of buildings by 2040.
Good. There's one in the chat now. So just reading it through or paraphrasing slightly, to produce the same amount of energy, electrical energy emits more carbon than natural gas, which is true, especially in Australia where we've got a lot of coal-fired power stations. Since we want to become carbon zero, why is it important to electrify existing buildings? Is it because you are considering that in the near future, electrical energy will be produced by renewable sources?
Well, the answer is the grid has already decarbonised in, I think, every state except Victoria to be that electric solutions are already lower carbon than natural gas today. And by the time you are implementing these projects over the next, few years, the grid is just rapidly decarbonising. So even in Victoria, all state governments have set clear trajectories to get the grid down to as close to zero as they can by 2050. So if you use that carbon cost calculator, that carbon calculator tool, you can play with the boiler efficiencies and the heat pump efficiencies, you'll see that there's pretty much every scenario you can imagine. Electricity, even just using grid electricity, is a lower carbon solution than gas. And of course, you can buy renewable electricity, in which case it's zero greenhouse gas emissions. You can't deal with gas other than with offsets, and obviously they're problematic. And I think it's also important to note that there's a very limited amount of offsets. One thing we can do in buildings is get gas out of the buildings. Gas is buildings are a much easier opportunity to get to get rid of gas because the heating is very low grade. It's much more of a challenge in industrial processes, which is where green hydrogen is likely to form part of the solution. But in buildings, we've got all the technologies available today to get gas out. It's just a matter of just rolling that program out.
Okay, just jumping on to green gas or hydrogen, can we use that? And I know you've just sort of touched on it, but what are your thoughts on that? Industrial sounds like a goer, but what about commercial?
The big challenge with hydrogen, if you want to put hydrogen in buildings, you're going to have to change all the gas pipes. You're going to have to change effectively the infrastructure, because you can't just put hydrogen straight into gas pipes. The hydrogen molecules are much smaller, so you've got issues there. So if you want to use hydrogen in buildings, you've got to effectively redo the gas pipe infrastructure. Whereas if you want to put electric, you go to all electrification, the electricity network is already there. So I think another risk is, as more buildings move away from gas, the buildings that are left consuming gas will be paying for the maintenance of the gas infrastructure that is supplying gas to their buildings. And as you get a smaller and smaller number of buildings contributing to that, the cost of that will increase. So, we're already seeing that in new residential developments where gas companies are previously they would install the gas infrastructure at no cost because everyone had to connect to it. Now they're not really interested in providing gas to some developments because they don't see there'll be enough demand to recover their costs of putting all the infrastructure in.
Absolutely. That drives probably a nice little segue to finance. I know it costs money to electrify buildings. So is there anything out there at the moment that helps support electrification of buildings? And, where do you see that heading in the future?
Yeah, well, I'm not an expert on sustainable finance, but we're certainly seeing lots of opportunities there to obtain things like sustainably linked finance loans to roll that out. It's likely that there'll be government funding and grants available. You know, there's opportunities, people like the Clean Energy Finance Corporation. And then on top of that, you've just got investor demand. There's green bonds associated with the greening of buildings and portfolios. So there's lots of financial mechanisms out there. I'm not qualified to talk about those, but I'm sure if you go and speak to the investors and do the research, you'll find that there's plenty of opportunity out there to support the electrification of your portfolio.
Absolutely. And a one that comes up a fair bit in these sort of contexts is, can the electricity grid cope with all buildings going electric?
Yeah, so I've heard that come up a few times. And I think if every building tomorrow suddenly switched to electric, then clearly there would be a challenge with the grid. But that's not going to happen. The electrification of existing building stock is going to take a number of years to do that. At the same time that that's happening, so if we could electrify every building by 2040, that would be absolutely amazing. In that same time period, we're going to see a significant increase in electric vehicles and all the electric vehicle charging, so the demands on the grid for that. And at the same time that's happening, the power stations the coal-fired powers are being phased out, and renewable electricity is taking up more and more of a share. So what's happening is the grid is evolving and the grid is changing, and the whole electricity grid infrastructure is going to evolve irrespective of whether buildings go all electric or not. So the issue to think about is, we're going to electrify our building. How do we align it with the grid? How do we align it with grid stability and managing peak demand? So we're going to see more of a shift from the focus on consumption being the really key driver to how do we maximize the use of the electricity that we need at the times of abundance, when there's an excess, a surplus of electricity in the grid, when it costs almost nothing because there's so much renewable energy being produced. And how do you minimize the consumption of electricity when it is more expensive? And so I think we're going to see the way that people are charged for electricity, consumers charged for electricity, change and evolve. And so demand management is going to become a key part of that. So when you're designing the electrification of your buildings, how do you sort of factor that demand management in? So for things like domestic hot water, which in some buildings is very small and in other buildings is a very large component of energy, the use of thermal storage is effectively an energy store that allows you to run your heat pumps when it's advantageous to do so and the electricity is really cheap, and then use the water at a time where the energy might be more expensive. So I think there's just some rethinking around time of use. I know that anyone that's got PV on their roof is already thinking about how do you make maximum use of the electricity, because you'll soon be charged to export electricity to the grid, because when there's a surplus, you'll have to pay to get rid of it or cut it off. So I think it's going to change is the answer, and electrification of buildings is not going to cause the grid to fall over. There might be challenges at some local level with local infrastructure, but that's likely to be a challenge when you put electric vehicle charging in as well. So I think it's going to evolve in the same time frame that we're talking about.
Yep, and that's probably answered part of the question in the chat at the moment that someone's put up. But I mean, to touch on it at an asset level, which David just did, I think the battery side of things is one way to do that. Local solar. Also, any new build that's put in around the area will have increased substation capacity, which will then enable local surrounding buildings to pick up that extra electricity and so forth. So I think, along with us trying to do this, the supply authorities are looking at what the future is going to bring too, which is an important part of this whole cycle of improvement. I've got another one up there at the moment. Hopefully, battery storage for domestic use will improve our tech and return on investment in the future. So more of a comment, which is true. So hopefully, all those things get cheaper on the battery side. I mean, there's some areas of battery technology that hopefully the world catches up with pretty quick as well. We'll probably do one more unless a couple pop up in the chat. But I think one that sort of popped up, what about embodied carbon in equipment? Does this make it better to stay with natural gas until the end of life?
Yeah, well, thanks, Gary. I think that was a question that popped up when we were doing the Green Building Council guide. So we did an analysis of that using both grid electricity and using renewable electricity over a 20-year period. If you've just put new gas boilers in a building, what's the embodied carbon impact of that, of replacing those gas boilers with heat pumps, well before their end of life? Well, if you look at the embodied carbon compared to the emissions associated with the operation of that equipment, all the numbers show you that it's still far better to get the gas out of the building because of their emissions profile. So yes, it's important to consider embodied carbon. It's also important to consider refrigerants and the type of refrigerants, and absolutely minimizing refrigerant leakage. And with at the moment, a lot of heat pumps have high GWP, and what we will see is more heat pumps coming on the market, for space heating and domestic hot water that have much lower GWPs. I know domestic hot water you can get CO2 heat pumps, but we're going to start to see much a sort of race like there is with chillers to get really low GWP. We'll start to see that emerge, but consideration of embodied carbon and refrigerant leakage is also important, because that's all part of the whole carbon footprint. But it's a bit of a no-brainer when you look at it over the next 10, 20, 30 years. You've got to get gas out of the building. And the factors that you use also make gas appear to be less harmful than it is. Gas or methane leakage in particular, which is the sort of scope 3 emissions, like embodied carbons are scope 3. The methane emissions are, when you look at them over a 20-year period, and over the next 20 years, that's pretty crucial from the climate science. The impact of methane is 3 times higher than the factors suggest, because the factors are over a 100-year period, averaged over a 100-year period, and methane's biggest impact is in the first 20 years, and then it breaks down. So there's lots of things to consider in the carbon footprint, but I'd encourage you again to go and have a look at the GBCA guide and the graph in there on that issue and the assumptions, and you can do your own numbers and show to yourself that the embodied carbon, whilst it's important, is outweighed by the natural gas emissions.
Just we'll probably wrap up there. I think a couple more questions have popped up in the chat, Dave. I don't know whether you've got time to quickly run through those, or we'll answer those at a later date. You want to have a quick read? Do you want to give them a shot, or we'll come?
Yeah, well, I think Isu's raised the issue there of fire pumps and instead of diesel for fire pumps. Look, yeah, this electrification resource pack doesn't really dive into that. You know, it recognises that diesel use is an issue for fire pumps and for generators, but that's probably a challenge for another day. This pack is really just focused on the big challenge of getting gas out of the buildings. There's clearly a need to address diesel. The challenge with diesel and using things like biodiesel is around storage and stability of biodiesel over time. So, you know, I think that's probably another guide somewhere down the track to help people with diesel. And
it's fair to say the codes will probably need to do a bit of catch up, including fire engineering and these sorts of things. So I think that probably starts to answer Isaru's question in terms of that there's a bit to do from a government point of view as much as there is of a design point of view. Do you want to quickly tackle the circular economy? Has that been considered in the tools in respect to end of life of gas infrastructure materials or / materials?
We didn't cover the emissions associated with disposal of equipment. I mean, it's a good point. I think circular economy is gaining a lot of momentum, and it's understanding how to apply that in buildings, and particularly the in building services. What you do with the kit when it gets to its end of life, or if you're replacing it sooner. Again, I would say when you're looking at the carbon footprint, that is something that can be added in. If you're replacing kit at the end of life, then you'd be replacing it anyway. If you're replacing it early, it forms part of that embodied carbon calculation, and how much of that gets recycled. So yeah, I think there's a lot of work needs to be done on circular economy in building services in particular, and also in embodied carbon. It's I know SIBS is doing a lot in that space, but it's still a new field and has got a long way to go before we've got great confidence in what's the carbon going into all the equipment that we're producing, and what's the carbon footprint of the disposal of its end of life, and how much of that can we start recycling back in to the chain.
All right. On that note, we'll wrap it up. Thanks so much, David Clark, for presenting. Quick reminder that all the resources can be downloaded from the Better Building Partnership website. I think there's a link in the chat if you want to take a copy of that. And there'll be a recording put up, or this recording up on the website in the next few days. Thanks again, David Clark, Better Building Partnerships, City of Sydney, plus Cundall, and collaboration with Positive Zero. So thanks everyone for joining.